And question number 8 says the base of the pyramid is a square, and that base pyramid is going to be a 4 by 4 square, and the height of that pyramid is 3 centimeters. It says, part A says, what is the angle of elevation from the corner to the vertex? So I've drawn that blue angle there from the corner. So I've drawn that blue line from the center to the corner C, and that angle made there in the right triangle. So I've made my right triangle off to the right, made with V, O, and C. That angle is going to be the angle of elevation that we're looking for. To find an angle in a right triangle, we need to have at least two sides. We only have here the height of 3 centimeters. So what we're going to do is we're going to use that yellow triangle to find the length along the hypotenuse, and that length is going to be the bottom of that blue triangle. So I've outlined that triangle on the base in yellow, okay? And that triangle is going to have length of 2 on both sides because it's halfway through the square. And using Pythagoras, 2 squared plus 2 squared is going to give me 8. So the length along that diagonal is square root of 8. So then this length here is going to be square root 8 along in the blue triangle. Now we have two sides in the blue triangle to be able to solve that for angle alpha. So I'm just going to write here, the ratio we're going to use is tan. So we have tan alpha is going to be equal to 3 over the square root of 8. Or in other words, angle alpha is equal to the inverse tan of 3 over square root 8. I can type that into my calculator. 3 divided by square root 8, we end up with 46.686, so 46.9. Sorry, 46.69. And round that to 0.69 degrees. So that is that angle of elevation along that diagonal line up to the vertex. Part B says, what is the angle of elevation along the slant height line? Well, the slant height line, I'm going to draw in red here. So that's going to be this line from the top to the center of the triangle. And then we're going to make a right triangle here. And that right triangle, that red right triangle, is going to allow us to calculate the angle of elevation, which we're going to call beta. So that red angle there is the one we want. The line from the vertex to the middle of the triangle made with the base there. So drawing that triangle in, so it's going to look something like this. Maybe we draw that. So I have my right triangle. Okay. We know that the height of that right triangle is 3 centimeters, and we don't know any other side. So we want that angle beta. Now it happens that the bottom of that triangle is going to be the same as halfway across the square. So that bottom is going to be 2 centimeters. Well, once I have two sides of the right triangle, I can then calculate the angle. So I know that tan beta is equal to opposite over adjacent. That means that angle beta can be found using the inverse. And when I inverse that, angle beta works out to be 56.309. So I'm going to round that to 56.31 degrees. Okay, so that angle of elevation made with the slant height line, that red line through the center of the triangle, that angle is going to be 56.31 degrees.